So I'm going to go over 8.2, Probability and Counting. So we have two terms that we're going to talk about. If we have two different events, the union of the two events is all of the outcomes in either of them. So if we were to do a Venn diagram, it'd be everything in this circle and everything in this circle. The symbol for it is going to be A with it's sort of a U. It's not really a U, but it looks like a U, B. The intersection is the one that's common to both. So in a Venn diagram, it's just going to be the overlap. That one's symbol is upside down version of this. So union kind of looks like a U, intersection is that symbol there. Okay, so let's use an actual example here. So let A be the event that the spinner lands on a vowel, and B is the event that it lands on letter J. We're going to find the A union B. So I'm going to use some set notation here. So A is our vowels. So looking on our spinner, I have an A, an E, another A U, and an O. My B is that it lands on a J. So looking at it, I have two J's. So J, J. So if I wanted to find the union of those, that's going to be combining all of it. So A, E, A, U, O, J, J. All right, probability. Find the probability that event A or B will occur. So or is a good word there. The probability that A event or B event occur is the probability. So this is probability, P, of either A happening or B happening. Well, that's going to be our desired outcome, which is any of these, over the total number of options, which is our sample space. So here we've got 1, 2, 3, 4, 5, 6, 7 outcomes that are favorable. On our circle here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible outcomes. So we can do this, 7 out of 10. You can write it as 0.7, or you can write it as 70%. Those are all acceptable ways to represent probability. So I want you guys to try the next two. All right, and our next here, this wanted the probability of pulling a letter from the alphabet at random. What's the probability that it's a vowel? Well, we have 5 vowels out of 26 letters. So 5 divided by 26 gives us 19%. The probability that you're drawing a card randomly and it is a 2 or an 8. Well, there are 4 2s and there are 4 8s, so we have a total of 8 favorable outcomes. In a deck of cards, there are 52 cards, so that's something that we're going to use a lot. 8 divided by 52 is 15%. The complement of an event A is all of the outcomes in the sample space not included in A. So how you'd calculate the probability of not A is going to be 1 minus the probability of A. So our example 2, a school has photography display 100 pictures. One of the pictures is to be chosen randomly for the office. Lorenzo has 3 pictures on display. What is the probability that one of his photographies is not chosen? Well, we have 100 different options, so that's our sample space. He has 3, which leaves 97 options that he's not chosen. So unfortunately for Lorenzo, he has a 97% chance of not getting his artwork displayed. Okay, let's look at some more. If there's a 4 in 5 chance that your mom will tell you to clean your room after school, what is the probability that she won't? Well, if there's 4 out of 5 she will, there's a 1 out of 5 she won't. So 20% chance mom's not going to tell you to clean your room. Okay, what is the probability of drawing a card from a standard deck and not getting a spade? Well, there are 4 different suits. So of those 4 suits, if I don't want a spade, that remains 3 others: clubs, hearts, diamonds. So there's a 75% probability that you will not choose a spade. All right, you try the next ones. All right, what is the probability of not landing on tails? Well, that's 1/2. Not rolling a 6 is going to be 5/6. And then if 90% are right-handed, that means 10% are not right-handed. So that is your introduction to probability.